Okay, so welcome everyone. My name is Antton Alberdi. I am the project coordinator of the 3D'omics, and I will give you a short introduction, an overview of where this project is coming from. And also I will set the frame, the background of the project, and then give you an overview of who we are. And I will start by stating something very obvious, that we are in a sustainability crisis. As we all know, the resources are limited, and we are forced to make all our production processes as sustainable as possible, as efficient as possible, and that's one of the main objectives of the European Commission. And the European Commission, since many years ago, is putting a lot of money into research in order to create more efficient procedures and also to inform policymakers to make new policy. And this is the general frame which 3D'omics is framed. So within the European Commission's investment and research. As you might know, in the last 7 years, there was a huge program that was called Horizon 2020, and 3D'omics is a project that is part of the Horizon 2020, but it was funded in the very last year of this program. And as you might know, that now we are already in the Horizon Europe era, but there are some differences, but this is just for technicalities. We are part of Horizon 2020 program. But in Horizon Europe, there are many other projects with similar goals and using similar technologies, etc., that will be addressing similar research goals, and we are interconnected with many other projects in the European continent. Our own project is part of this topic that was released in a 2019 call. It's called Healthy Terrestrial Livestock Microbial Ecosystems for Sustainable Production. So what the European Commission was requesting was to develop some activities that would address relevant microbial ecosystems of terrestrial livestock and to investigate their effects on the production, health, and welfare of animals. It was as broad as you can see. The description was pretty broad. And then they were requesting some more specific issues, like we had to characterize the microbial ecosystems associated with production animals. We had to assess the variability within and between the breeds in different production systems. We should assess as well possible ways in which these ecosystems can be managed, incorporate this information on microbial ecosystems into the models used to analyze phenotypic variability in production animals, etc., etc. So within this broad umbrella idea, there were some specific requests that the Commission wanted us to accomplish. But by that time in 2019, we were working on another European project called Hollow Foods, that it was addressing very similar aspects. So we were addressing generating multi-omic data, not just of the microbial communities associated with the animals, but also with the actual animals, and trying to understand how these interactions between hosts and microorganisms were shaping phenotypes or production indices, so indicators of these species, and try to come up with new strategies to improve these production processes. So when we saw this call, let's say, well, we are already doing what the Commission is requesting in this other European project. So we thought it was an excellent moment. So it was a huge opportunity to make one step ahead and propose something that nobody had done before. And that was to try, understand, reconstruct these animal microbial interactions at the microscale scale and in 3 dimensions. So as you might know, the microbial communities associated with animals and in the gut intestinal environment are not randomly distributed across the lumen, the mucosal barrier, the crypts of the pili, etc., etc. They have they exhibit three-dimensional spatial structure that, when we use conventional metagenomic tools, for instance, to reconstruct them, we completely disrupt this spatial information. We completely lose what is the locality or what is the position of specific bacteria, the genes that are being expressed, how close they might be to the mucosal barrier or to a specific cell, host cells, etc., etc. So we thought that it was the time to try generate this data, but keeping this spatial information so that we could really ascertain whether the activation of a specific genes, the production of a specific metabolites was triggered by the close connection between two bacteria, the close connection between a bacteria and a host cell, etc., etc. And this is where the idea of developing this project, 3D'omics, came. So I had this idea and started discussing with some colleagues, initially internally here at the KU, at the University of Copenhagen, with Tom Gilbert, with Urbish, which is who is also part of the project. And then also started discussing this with other partners outside the University of Copenhagen, such as Marc Martí from the CRG in Barcelona. Anna told me that, told us that perhaps people would be saying hi. So Marc, if you want to say hi, no. You're very welcome to do so.
I'm here. Thank you, Antton.
Good. So Marc then will give us some more information about their group and what they will be doing in 3D'omics. But then through Marc, we also contacted Anna Pombo at the Max Delbruck Institute in the center in Berlin. So hello, Anna.
Hello, I'm here.
And we also contacted Kati Hahineva. I don't know if Kati was able to do it in the end, but if she's not here, we can just continue. Then we also contacted other people that with different expertises, like Phil Pope and Itzik Mizrahi, Mickey Boyson also here at the University of Copenhagen, but working mainly on animal sciences. Michael Hess doing similar research, but in Austria. Then Annelies in ETH Zurich working on in vitro microbial community studies. Caroline Faust at Leuven working on microbial ecology. Sorry, Annelies, I jumped over you.
Yeah. Hello, I'm happy to be here as well.
Thanks. And then also some commercial partners, so some companies like Norsvin with Ellie, as well as Aviagen with Santiago, and Biomin, now DSM Biomin with Veronica and colleagues. I think Veronica is around.
Yes, hi everybody.
Hi. So in total, we created this consortium of 13 partners from 11 different countries, and so encompassing 6 universities, 2 research centers, and 5 companies. And all these different partners have very different expertises because we will be interacting people with expertise on genomics, microbiology, metagenomics, structural genomics, animal science, metabolomics, data science, microscopy, and I could continue adding more and more words here. But the key message here is, it is that our consortium is an extremely interdisciplinary consortium that's with people that excel in relatively distant research fields that we are all really committed to work together to really move the frontier of the research ahead from where it is right now. So these 11 partners created this project proposal, which was its short name is 3D'omics, but the long name is 3-dimensional holomic landscapes to unveil host microbiota interactions shaping animal production. So it can be quite complex. So we try to avoid using this this very long title. But basically, 3D'omics is a project that started in September 2 months ago and will be running until August 2025. And it has a budget of 10 million euros for doing the research that we promised the European Commission we would do. And this is the overall structure of the project. We have 9 work packages that are clustered in 4 sections. There is one section that is dedicated to management and dissemination, exploitation, and communication with 2 work packages. Then we have one section on technology development with 3 work packages in which we will be generating and developing new technological approaches to generate these microscale 3-dimensional reconstructions of animal microbiota interactions. Then once this technology is developed, we will transition into another section with 2 work packages in which we will showcase or we will implement this technology to address issues that are of relevance for the industry in Europe, for poultry industry as well as swine industry. And in the end, we will have 2 other work packages that will be dedicated to assess the implementation of this technology in industry, research, and beyond. So our idea is that the part of the technology development will last about 2 years, starting now and until the end of 2023, more or less. It will be overlapping also with the technology showcasing, because we will be running some experiments, some trials, animal trials that will last over a few months. So then we'll be, once this technology is developed, then we will be implementing on these trials. And in the end, in the last year, we will be assessing this technology and the impact of this technology in research and in industry. So regarding the first part of the project, technology development, this is a complex figure that we created, but it will give you an idea of what we are already doing. So in this first part of the project, we are running some proof of concept trials. These are small scale animal trials that are aimed at generating the initial samples that we'll be using for starting to develop this technology, as well as to feed the in vitro analysis that we will be also running with analysts in ETH Zurich. Then we will be slicing and microdissecting these samples and then working in 2 different aspects, working on generating data, nucleic acid data, genomic data, transcriptomic data, and metabolomic data. So using mass spec technology. And then all this information, along with imaging data, will be digested by Mark's group at CRG in Barcelona for generating these 3-dimensional reconstructions that will enable them to do the actual research on understanding these interactions between animals and microbiomes by using this new type of data to analyze this. Then once this technology is developed, we will showcase it in different experiments, and we will be running 5 experiments in total. 3 will be on poultry, then we will be mainly addressing health challenges, and there will be other 2 trials that will be on pigs and mainly addressing nutritional challenges. For the poultry, we'll be running 3 trials, one with an adenovirus challenge, another one will be with a salmonella challenge, and the last one with a histomonas challenge. The 3 experiments will have different study designs that will be addressing different questions, but the common topic is that we'll be addressing 3 pathogens that are nowadays affecting the poultry industry. And then for the swine part, we have 2 experiments, one dedicated to digestibility and the other one testing prebiotics. And in these experiments, we will be testing different products of commercial partners like Biomin's Poultry Star Feed Additive, Aviagen's Ross 308 broiler chicken line, Northwind's TN70 swine line, and Veterinary University of Vienna's vaccine against the histomoniasis. So researchers from universities and research institutes will be collaborating closely with industrial partners to address all these questions by this industry-academia collaboration. And then in the very end, we will be implementing and assessing the results, and not just how good or how accurate the results that we generate are, but also what would be the economic impact and the social impact of implementing this technology in the short term, mid-term, and the long term. So right now, the consortium is comprised by all these people that are shown here and more. So we are about 30 people working in 3D'omics right now, but we need to recruit new people. We need to recruit postdocs. We need to recruit research assistants, etc., to make this research possible. So this is why we decided to organize this event, so that we can show you firsthand what we are planning to do. And then we would also like to interact with you to know what are your concerns, your questions, and then we can know each other better.